Okay, so we are starting from question 1, the document which I've just shared in the group. So like I said, we are going to do vectors, linear motion, and projectile motion. Then at night, at 21, we are going to do Newton's laws of motion. It's going just to be alone. So the first question is vector A. A vector A has a magnitude of 30 meters at an angle of 200 degrees with respect to positive x-axis. If we add vector B, it is found that the resultant is along the positive x-axis and has got a magnitude of 10 meters. What is the magnitude vector B and its direction? 10 marks. This question came in in last year's final exam. So what's the first thing are we going to do for us to get all 10 marks? Okay, what are we going to do? We are discussing.
Draw a free body diagram.
Yeah. So the first thing in physics, guys, when you read the question, the first thing should come in your mind is to come up with a free body diagram. Okay? A free body diagram is something that you yourself, the way you understand the question, and then you come up with any diagram. It's not that you are going to come up with a diagram which is going to interpret this information exactly, no. But you're just coming up with a free body diagram. Okay? So mostly when you're talking about vectors, you can just come up with an xy plane. Okay? Here is my xy plane. Then if I want, I can say, I can say this is y, this is x. Okay? That's all. If I want, I can say, I can put north on top, south here, east, west. It's fine. Okay? And then now I need to start now putting these vectors. We've got vector A. Vector A has got a magnitude of 30 meters at an angle of 200 degrees. Where can we find 200 degrees?
In the third quadrant.
In the third quadrant. So in the third quadrant, I need to come up with this vector. I'm going to draw just here. Then I'm going to say this is vector B or vector A. This vector has got a magnitude of 30 meters. Then from this line here, we're measuring the angles from positive x-axis. From this line here all the way to that line. That is what? 200 what? Degrees. For vector A, I'm done. Vector B, I don't know what vector B is, but I have the resultant. Okay? So they are saying that it was found that after adding vector A and B, the resultant was going in the what? Positive x-axis, and it has got a magnitude of 10 meters. So when a vector is moving along positive x-axis, what is the angle? Aaron. Aaron, if a vector is going through positive x-axis, what is the angle? Okay, Aaron is still thinking. Messi.
Also, I think it's 90.
It's 90. Messi is saying 90. Nori.
So I'm still thinking.
Still thinking. Irene. Maxwell is saying the angle is 0. Aaron, you are also saying the angle is 0, right? I've just seen your... Okay, let me just explain there. If you have got an xy plane, Then they are mentioning to say the angle is moving toward positive x-axis. The angle is 0 degrees. If that vector is moving toward positive y-axis, the angle is 90 degrees. If a vector is going toward negative x-axis, the angle is 180. If a vector is going toward the negative y-axis, the angle is 270. Now, if a vector is going toward the positive x-axis, sometimes you can also say you can say 360, but I don't want to tell you that it's 360. I'm going to stick to 0 for now. So based on this information, Nori and Messi, this resultant vector was going toward positive x-axis. What is the angle?
0 degrees.
We are okay, right? That's 0 degrees. Now, sometimes they are going to use different things. They are going to say the resultant is moving toward east. So east is the same as positive x-axis. South, north, west. It's the same thing. When they're talking about toward west, then it's 180. North, 90. South, 270. East, 0. Are we good to go, guys? So meaning that this vector, which we know that is a resultant vector, is moving toward positive x-axis. Okay? So I'm going to put the resultant here as r to be equal to 10 meters. As simple as that. Now, the next thing which I have to do after coming, this is what we call a free body diagram. I've come up with a free body diagram. What's next? As long as you are dealing with vectors, resolve each vector into x and y component. This vector, as long as you understand this principle, guys, is very easy and straightforward. Okay? After coming up with a free body diagram, resolve each vector into x and y component. Then add the x component alone, the y component alone. Then find what is missing. That's all. Let's start. We are starting with a. So we are resolving a into x component. So if you are resolving a vector into x component, what do we do? Irene.
I didn't hear the question, so what did you say?
The question is, if you are resolving a vector into x and y component, what do we do? So let's start with x. For example, in this case, we want to resolve vector a into x component. So what are we going to do? Irene, we are still waiting for you. So Irene doesn't know. Silent means a lot. Messi, what do you know?
I was saying that if it's in the x component, we use the cos, and if it's in the y component, we use sine.
Okay. So in this case, we're going to say a cos theta, right? So it's going to be ax. My a is 30. The angle is 200. From today onward, the moment you hear to say we are having a class for physics, you need to have a calculator. So what is 30 cos? I'm getting negative 28.19. that correct? Do you have anyone who has got a calculator?
I have, sir. It's correct.
Now, guys, listen. Mute your mic, Messi. I like it when I'm teaching physics. I want people to understand such that when you are solving, before you go to the next step, you'll be able to know that this is a mistake. You get my point, right? Let me share one thing to you. I enjoyed um I want you to become like the students I had in 2022, whereby when I teach them, sometimes when you are solving tutorial question, they will be able to tell me to say, no sir, there you have made mistake. In this case, that's why when you understand vectors is more like the building block of physics. Because if you don't understand vectors, you can't solve any question under Newton's laws of motion. It's practically impossible. If Newton's laws is giving you nightmares, you can't solve questions under work, energy, and power. Again, if you understand vectors, you understand Newton's laws of motion and work, energy, and power. Boom. When we go now to circular motion, it's going to be very much easy for you. Now, I want you to understand physics in a such a way that when you are solving, and don't feel bad even if you don't know anything, you you are going to enjoy, believe me. Here, I want you to know in which quadrant is A, in which quadrant is vector A. Hmm? In which quadrant is vector A? Yes, please. In the third quadrant. So now, you discover that in the third quadrant, do we have is x negative or positive? Yes, it's negative. What of y in the third quadrant? It's negative, right? So you discover that if we go, if we talk about cos there in the fourth, in the third quadrant, is it negative or positive? Hmm? Is cos negative or positive in third quadrant? It's negative, definitely. Even when you are solving this question, you'll be able to know to say, okay, so the x quadrant, the x component, since it is in the fourth, in the third quadrant, cos in the third quadrant is what? It's negative. So definitely the answer is going to be positive. Then you are punching on your calculator, you discover that the answer is positive. What the first thing should come in your mind is that no, I've made mistake. Let me redo it. Okay? Definitely you have made a mistake. Redo it. That's why under vectors it's practically impossible for you to make mistake because you'll be able to know to say, okay, yes. Okay, you can mute your mic. Is your network stable? Ngonya. Okay, mute yourself When you ask the question, then you mute your mic. So I'm saying, in the third quadrant, cos is negative. Definitely, when you're resolving this vector into x component, it has to give you negative. So if you are punching on your calculator, then you discover that it's positive, just know that you have made a mistake. Okay? Just know that you have made a mistake. So here, if I do 30 direct, before I even punch, I should know that the answer is going. I don't know the answer, but the answer should be negative. So 30 cos 200. 30 cos 200 is negative 28.19 meters. I leave it there. I need to resolve again this vector into y component. Again, I know that when we're talking about y, it's going to be a sine theta. Is sine positive or negative in the third quadrant? It's negative. Definitely, even if before you find this, you'll be able to know that the answer should be negative. As simple as that. So what is 30 sine 200? It's
Negative 10.26.
Yes, 10.26. Guys, are we okay there? So you should know that when you're dealing with the first quadrant, sine and cos, they are positive. Definitely the answer is going to be positive in that case. Okay. Vector b, I'll just say bx and by. We don't know. Vector, the resultant now, we can resolve the resultant into x and y as well. So we start from here. Rx will be equal to r cos theta. So what is r? R is 10 cos 0. What should come in your mind in that case, if you have really understood what I've said? Is it going to be positive or negative? It is in the first quadrant. What is cos in the first quadrant? Is it negative or positive?
Positive.
Positive. So definitely cos 0 is going to give us 10. Then again, I'll say ry will be r sine theta, which is 10 sine 0. So still is going to be positive, which is going to give us 0. On resolving vectors into x and y component, who is still behind? Please let me know. Messi, your hand is up.
Sir, it's fine. I wanted to ask a question. You already answered it.
Please ask. Okay. Now, after resolving each vector into x and y component, you know that this is the resultant. Okay? When you add, so we are starting with x, so we're going to say the rx is a result of ax plus bx. As simple as that. Okay? Then from there now, we are going to say the rx. What is rx? Just put what is a variable. The one which is missing is going to solve. It's going to be easy for you. So rx, we have already found that is 10. What is ax? Ax is negative 28.19. What is bx? We don't know. That's what we're trying to find. Shift this guy to the other side. So you have 10 plus, now that was negative, is going to be plus 28.19 is equal to bx. Meaning that my bx is now 38.19 meters. Allow me to put it here. So it's going to be 38.19 meters. As simple as that. That is my bx. Okay? Let's go ahead and find. Even if you don't know what you are finding, in this case I'm assuming that I don't know what I'm finding. So I'll just put rx or ry is going to be ay plus by. Okay? So what is ry? Do we have ry? Yes, we have. It's 0. What is ay? Do we have ay? Yes, it's negative 10.26. Do we have by? No, it's the one we're trying to find. Shift negative 10.26 to the other side. You have 10.26 is equal to by. Okay? Then, meaning that your by now is 10.26. Like that. Before you even solve vector b, from the component itself, we can know where this b lies. The x component is positive, the y component is also positive. Where do we expect this b to be? Is it in the first quadrant, second, third, or fourth? Now I can get rid of these. I no longer need them. It's going to be in what? It's going to be in the first quadrant. Since x is positive, y is also positive, definitely it's going to be in the first quadrant. In the first quadrant, that's where we can see that x is positive, y is, or you can just think of this, x, we're not talking about x, it's the cos, y is a sine. So in a quadrant where both x and y they are positive, is where it is in the first quadrant. The question here is saying find the magnitude and the direction of vector b. Direction is the angle. Since you have identified that it is in the first quadrant, what should come in your mind is that the angle should be between 0 to 90. It can't exceed 90 because it is in the first quadrant. So let's first now find the magnitude of vector b. To find the magnitude, you put an arrow on top to show that it's a vector. So it will be bx squared plus by squared. So my bx is 38.19 squared plus 10.26 squared. Those having calculators, what are you finding? So 10.19 plus, or we square it first, plus 10.26 squared. The answer I get is the square root. I'm getting 14.46. Can you confirm? Can you confirm? Nor you said you have got a calculator.
Yes, I have a calculator.
So is the answer correct?
That is interesting. So I'm getting 39.5.
You are getting 39 point. Let me redo it. Oh, this is 38, right? I punched 30. 38.19 squared plus 10.26 squared. Okay, 39.54.
Yes.
Okay. 39.54 meters. Okay. Now, this is the magnitude. But we need to find the direction. The direction is the angle. Like I said, you have already identified that x is positive, y is what? Y is also positive. Definitely this angle should be in the first quadrant. If the angle falls in the first quadrant, then when you use that formula for tan, the answer you're going to get, that is your final answer. Since we know that this formula is theta is equal to tan inverse ry, so in this case it's by divided by bx. Okay, so theta will be equal to, in this case we are going to say tan inverse by is what? Is 10.6. What should come in your mind is that the angle should be between 0 to 90. It can't exceed that, then we have made a mistake because it is in the first quadrant. So if you punch on your calculator, shift tan open brackets 10.26, you divide this by 38.19, I close the brackets. The answer I'm getting is not making sense. What are you getting? Shift
15.0378.
10.26 divided by 38.19.
Me, I'm finding 15.03.
I'm also getting 15.037, which is the same as just 15 degrees. So 15 degrees is my angle. Okay. Another thing about vectors is if the angle falls in the second quadrant. I think I explained last time, right? And you have watched that video, I believe so. If the angle falls in the let's assume that we are finding this 15 degrees, but it falls in the first quadrant, or sorry, in the second quadrant. Are we going to conclude that this is the final answer? Are we going to conclude that that is the final answer?
No, sir.
What are we going to do if the answer is no?
Going to add 9 to the answer which we found if it's in the second quadrant.
We're going to add 90.
Yes.
Okay. So you mean if we find this, then we add 90, that will be our answer? Okay, let me do this. You subtract by what? Where is that 200 coming from? Or you mean this 200? 180, yes. Yes, so if it falls in the second quadrant, you subtract 180 minus the angle you have found. If it falls in the third quadrant, you say 180 plus the angle you have found. If it falls here, you say 360 minus the angle you have found. That is very important when it comes for the vectors. I'm going to... That other day we were doing vectors, I explained this, right? Who managed to get this question correct? Those who submitted these answers.
I think I managed to get this one correct.
You are sure?
Yes.
Okay, that's perfect. What of that question 2? I want us to read this question and then analyze it. So this question is saying, three horizontal ropes pull on a large stone lying on the ground, producing the vector forces A, B, and C. Find the magnitude and direction of the fourth vector or fourth force on the stone, that will make the vector sum of the four forces 0. What comes in your mind when we say the resultant is 0? If we say the resultant is 0, meaning, are we interested to know the angle of that resultant? Are we?
No, we are not interested
Why are we not interested?
because the resultant is 0. Meaning where there is resultant, we are going to replace with 0 because everything is 0 that side.
Okay, so now,
Meaning what are we doing?
okay, thank you, sir. So now, here what it means, guys, is it's the same explanation which my guy has just explained. We're not talking about 0, because if we say Rx is equal to R cos, we don't know the theta. 0 times anything is going to give us 0, meaning that the resultant, the x component of the resultant is 0, the y component is 0, then the rest can follow, not so. You know, there are some people who don't want to waste time. You can still do this. In this case, you can say Rx will be equal to, how many vectors do we have? We have got vector Ax, Bx, Cx, then D is the one we are trying to find, Dx. So this is going to be 0, then Ax is A cos theta, Bx is B cos theta, C will be C cos theta, D we don't know. We just put it like that. It's the same, not so? If you want, you can do like the way I did it in the first question. So here I'll say 0 is equal to my A. What is vector A? Vector A is 100, because the angle is, this angle is coming from positive x-axis. I'm going to use the same one, 30 degrees, plus B is this one, 80. What angle are we going to use for B for us to resolve this vector? Yes,
120.
120. Why 120?
Because it's in the second quadrant, so we're going to subtract. Oh, so we're going to add.
We're going to add what?
We're going to add the 80. So the 30.
30 to what? We are going to add it to what?
We're going to say 30 plus 180.
30 plus 180 is 210. 180 minus 30 is what, guys? 180 minus 30 is indeed 170. No, 180 minus 30 is 150. 150. Okay. Nori, yes.
As for me, what I know is that to add 90, since we're going to calculate the angle from the positive x-axis, so add 90 to 30. That will give us our total angle.
Okay. Okay, so when you are dealing with vectors, like I said last time, you measure the angle from positive x-axis until where the vector is. So from this line all the way to this line is 90. But again, we've been given this part here is 30. So it should be 90 plus 30, which is what? 110, not so? 120. It's 120, right?
Yes.
And then vector C is 40, because the theta now. What angle are we going to use in the third quadrant now that this is 53? So we want to get, which angle are we going to get in that case?
233.
233. Why 233, sir?
According to explanation in your previous video I've watched, you said when getting the angle you get from positive x-axis. So we start from where there is a 30-degree, where there is vector A going that side. So we add 180 plus 53, which is giving me 233.
Perfect. So 233. If there is any question there before we move, can you please ask? The reason why we are getting 233, we are getting the angle from positive x-axis until where the vector is. So we start from where x is until where the vector is. So we know that reaching at this point is 180, but we've been given this part already as 53. So 180 plus 53 is 253. As simple as that. Okay, now we can use our calculators to find the answer. So 0 will be equal to, so we have 100 cos 30 plus 80 cos 120 plus 40 cos 233. Those having calculators, please help me. I'm getting 22.53.
Yes, it's correct, sir.
Thank you. So if I shift this to the other side, it's going to be negative 22.453 as my dx. I can put it here. Dx is equal to negative 22.53 newtons. Any question here before we go to the next step? Now, I want you to be thinking so widely, guys. When it comes to physics, this is one of the simplest course. The only possible quadrant where we can find D right now, we have only solved the x component. The only possible quadrant where we can find vector D is which one and which one?
2 and 3.
2 and 3. Is 2 and 3 because that's where we can only find the x to be negative. You get my point, right? So now, y is going to tell us, is the one which is going to tell us to say, oh, it's supposed to be in the second, or it's supposed to be in the third one. Can we go to y now? So ry will be equal to ay plus by plus cy plus dy. Ry is 0. A is a sine theta plus b sine theta plus c sine theta plus d sine theta. So 0 will be equal to, we definitely know that a is 100. Did we use 100 even here when calculating for x? I've forgotten. B is 80. So we use the angle which was what? 120, right? The angle will be the same. C is 14. The angle will be the same. We said 223 or 233. We said 2 what? You're able to get me? Okay, are you able to get me? I was asking, are you able to get me?
Yes. This is when we are actually getting you.
I lost my network anyway, but we are together there, right? I was just writing. Unless you have questions. Okay, so we can continue, right? The angle here we found, was it 223 or 233 for vector C?
233.
233. Then d is the same as just writing dx is fine. dy, sorry. Grab your calculators. 100 sine 30 plus 80 sine 120 plus 40 sine 233. I'm getting 87.34. Confirm. Confirm. Shifting this nigger to the other side, negative 87.34 to be equal to my dy. Those having calculators, please confirm for me.
It's correct, sir.
It's correct, right? So I'll write here to say dy will be equal to negative 87.34. Perfect. So d, now I want to ask Nori this question. Nori, d is now negative. We said the possible quadrant where we can find this vector is only the third one and the second one and the third one. So we said y is the one which is going to tell us whether it is indeed in the third one or in the fourth one. So from what we can see here, y is negative. Where do we expect this guy to be? Is it in the first or second or third?
The third quadrant.
The third quadrant. So Nori is saying the third quadrant. Are we in support with our answer? Anyone who is in support with Nori's answer, tell us.
I'm also in support of it.
Okay. Who else is in support with Nori's answer? Who else?
I'm also in support.
Okay. So now, let's find this vector d. So you put an arrow on top. You see, these vectors, that's why here they have put arrows. It's a vector, guys. If there is no arrow or it's not in the modulus, then it is a scalar. It's not a vector. So don't forget to put the arrow. So you say your d arrow on top will be the square root of dx squared plus dy squared. So you say the root of my dx is negative 22.53 square it. Your dy is negative 87.34 square it. What answer are we going to find? Those having calculators, help me. Ignore the negative because you are squaring. So 22.53 squared plus 87.34 2.34 squared. The answer I'm getting, the square root of this is 90.199, which is the same as 90.2. Okay, after finding this, we need to find the direction. Since we have said the angle falls in the third quadrant, definitely the angle which I'm going to find using our formula theta is equal to tan inverse. I need to say that angle, since it is in the third quadrant, I'm going to say 180 plus that angle. Okay, theta is equal to tan inverse, in this case will be dy divided by dx. So tan inverse dy is, ignore any negative you are going to see when you are finding the angle, and follow these simple principles, please. So in this case, I'll just plug in dy as 87.34, my dy, this other one 22.353, like that. What will be the answer? Shift tan, open brackets, 87.34 divided by 22.53. I close the brackets. I'm getting my answer to be 75.5 degrees. This angle falls in the third quadrant. It's the same as 53 in this case. So once you discover to say the angle falls in the third quadrant, you have to say 180 plus the angle you have found. So what answer are we going to have? So if we do 180 plus 75.5, I'm getting 255.5 degrees. So this is my angle. Okay, sometimes some other people will tell you to say it is also important to know how to report the answers. It doesn't matter, as long as you give them, you know that this is the displacement. So if you want, you can tell them that, okay, so the vector d is going to be 90.2 meters at an angle of 255.5 degrees from positive x-axis. As simple as that.
Sorry, sir, meters or Newton?
Oh, sorry, newtons. This one you got it wrong. I saw your answers yesterday. There's no debate about it. Nori, your answer for, you had to put 75 degrees. No. So the correct answer is 255.5 degrees. That is the direction. Guys, on direction, let's pay attention, please. Please. Is that okay?